Good evening. Good evening, aspirants. Good evening, all. We'll discuss about transportation, story of roads today. The important concepts and the areas where the questions may come in 2022. So, transportation is having good weightage for gate point of view. Is a simple story with little fundamentals, little formulae, and mostly the formula oriented questions will come with a little conceptual oriented questions, because GATE is, what is the full form of GATE? Graduate Aptitude Test. So we get aptitude type of questions mostly in this area. Those things you can easily target it with little fundamentals of engineering mechanics also. Look at the syllabus of the GATE. GATE exam date has come now, 12th February. 2 sessions are there for civil, morning and afternoon session. For civil and mechanical, we have 2 sessions. For remaining all the branches, only one session for the GATE only. So the number of aspirants for GATE exam will be higher this year. Higher as usual, similar to the last year, and the other branches might have slightly reduced. So coming to the syllabus, transportation infrastructure, here mainly the geometric design is available. Geometric design of roads, railway and airport. That is the first topic. And highway pavements. Highway design, including the material properties, the flexible pavement design, rigid pavement design will be there in the second part. And next is traffic engineering. Sometimes it may create little traffic jam also. You have to be very careful about traffic engineering. Traffic engineering and the first part, transportation infrastructure, are having good weightage, and middle is middle weightage. So that is what generally observed from the previous year questions. So targeting good marks in transportation is easier, and especially if you want to join MTech structures in reputed institutes, you need to concentrate on non-structural subjects of GATE exam, like transportation, GT, environmental, like that you need to concentrate to join the structures in premier institutes. That means what I mean to say is you have good weightage on non-structural subjects compared to the structural subjects. So coming to the weightages, the chart you might have seen it, and look at the weightages. Weightages with years 2012 onwards, 2021. So you have good weightages given. GT is having higher weightage among all. Next is environmental, transportation, strength of material. This is the way we are getting it. Coming to the transportation, compared to GT and environment, the transportation syllabus is very less. Compared to GT, almost it is 40 to 50, 60% of the total syllabus. Even compared to environmental, the syllabus is less and weightage is reasonably good. You can look at this, the transportation engineering weightage, 2012 9. Slowly it is increased, slightly increased in 2014, and slight reduction in 2015 and 16, again peaked up in 19, 20, even 21, recent paper 9. 9 means almost 9%. 9 marks out of 100, 9%. 9% is a good weightage. And GT is having around 15, 11, like that. So, syllabus point of view, simple, easy, formula oriented with little fundamental, but if you are not very conscious in the exam, if you are concentrating very good on the exam in the exam hall, then you can get full marks. Even if slight deviation may cause mistakes, be careful. Especially we have to be very careful in the exam hall also, apart from the preparation level. First we will talk about the infrastructure, highway infrastructure, the main part is the geometric design. The highway geometric design, it is having 3 to 4 marks of weightage. Most of the times it is touching the higher mark, 4 marks. Maybe 1 2 marks question, 2 1 mark questions, or otherwise 1 2 marks question, 1 mark question from the geometric design. It is a big chapter. Formula oriented, fundamentals of mechanics also required here. As you know, you have the basic important topics I am talking about. In the 2020 onwards, the syllabus, slight variation has come in the syllabus. So, you have starting from geometric design and gradients and all, the historical development and other things they have not included in the present GATE syllabus. The historical development, the plans, the other things, the introduction part is not included in the GATE syllabus. That may be there in the ESA and other exams like SSC, JEE and all. So, you start with the geometric design from gradients. So, gradients, there is a chance of one theory question. Maybe IRC specifications they will ask you, like gradient, camber, grade compensation. Grade compensation is an important area from the gradients. Afterwards, you have the side distances. From the side distances, very commonly, very frequently you are getting questions from stopping side distance, very important area. Rarely we will get questions on OSD, overtaking side distance, not that important, but it is also from little fundamental oriented, mechanics oriented topic. Horizontal curves, you might be coming across this super elevation and all from your 8th class, 9th class onwards. And some people in SSC JEE preparation, they will start the JEE preparation from 6th standard onwards. So, it is very, very known area, very well known area, horizontal curve, super elevation. And setback distance, very small topic. If you concentrate, maybe a chance of 2 marks question directly. Transition curves, we introduced transition curve between the straight road and circular arc. Transition curves are also important, and vertical curves. We have 2 types of vertical curves, summit and sag curves. So, these are the areas very commonly important for GATE exam, apart from in the gradient, grade compensation. Okay? So, we will just talk about few simple questions. The theory questions may come from this area. Simple theory questions come from this area. Specifications are important. Specifications you need to memorize, you need to by heart. So, definitions may come, simple definitions, and simple instruments whatever you are using for different purposes, like what is unevenness index, how do you measure unevenness index, like that. Some little instruments they may ask you, but all the formulae you need to rattu, you need to by heart. So, every day you need to revise the formulae. Morning you need to spare some time, maybe some 20 to 30 minutes of time, and you need to revise the formulae. Even though you are very strong, very intelligent, the top-notch intelligent, you can derive the formula and solve the problem. But in exam, the main requirement is time. You need to solve it within time. So, you need to work accordingly. You need to act in a smart manner. For that, formulae you need to by heart. Even though you are topmost intelligent, you can derive and substitute and get the answer. The person who rutted the formulae can solve the problem just in seconds, earlier to an intelligent. Finally, the score matters. Whoever is getting good score and good rank will be treated as intelligent. So, be careful about the strategy of preparation. Formulae are very important, and specifications, not all the specifications of the code book. Important specifications which are frequently getting repeated, those things you need to concentrate. So, code book is important, but writing all the specifications of the code book is time waste. Because if you start by hearting all the specifications of the code book, is a never ending matter. Time is not sufficient. So you have to be very careful with important specification. By chance a specification has come from remote corner, leave it, because targeting such a remote cornered specification is very difficult, unless otherwise you work on that particular area. Okay? So see the type of questions. 1 mark questions may come, straightforward, simple, statement type of question. You can see this. Shape of the most commonly designed highway vertical curves. They have not mentioned whether it is a vertical summit curve or vertical valley curve. But whatever it may be, you need to go through all the options and go by process of elimination. Don't just pick up the answer, especially in theoretical questions, you go by process of elimination. Eliminate one by one, and most appropriate answer related to question you need to pick it up. So they are asking you related to vertical curve, what is most commonly designed in highway? Circular curve with multiple radius. Circular arc is the main circular curve, we use it, and that main circular curve is with the single radius. It is not the vertical curve. Spiral is a horizontal transition we generally use as per IRC. Circular with multiple radius, we generally use it for compound curves or otherwise for reverse curves. You might have come across in survey. So parabola is most appropriate answer. Actually speaking, summit vertical curves, we use second degree parabola. Valley curves, we use cubic third degree parabola. Anyway, vertical curve is parabola. Straightforward question, unless otherwise you have the concept and revision on the concept, you can't pick up within time. It can be, answer can be picked in maximum 10 seconds of time, not more than that. Such a simple question. Actually speaking, for 1 mark question, you have 1.8 minutes of time in GATE exam. For 2 marks questions, you have 3.6 minutes of time. So time is not a big criteria in the GATE exam, but however, such a simple questions you solve within a time less than the required, you can use that time for solving critical questions. At the end, BP may not increase. Usually what happens is you need to slowly answer. Your run rate will be slow in the initial stages. Then what happens is in the slag overs, you get lot of tension. You can't reach to the required run rate. Here run rate means question answering rate. You look at another simple question, straightforward direct question. Reaction time of driver, people won't read this. They'll just read reaction time of driver and go to the options. They're asking you reaction time of driver in overtaking side distance. In overtaking side distance, the reaction time is 2 seconds. In stopping side distance, reaction time is slightly higher. Based upon the PIEV theory, it is 2.5 seconds, that you know. So what I mean to say is, read the question properly, whatever is asked, identify and pick up the answer based on that. Look at another question. Highway is designed for 80 kmph. The design speed is given to us. Has a horizontal curve with a radius of 250 meter. Radius is also given to us. The design speed is, I'll take it as capital V. The radius of the horizontal curve is R. If the design lateral friction is assumed to develop fully, lateral friction is generally coming on the horizontal curve. They are saying that lateral friction is completely developed. That means you are making use of, you are mobilizing the lateral friction. So what is maximum lateral friction possible as per IRC? Longitudinal friction, whatever we use in stopping side distance is 0.35 to 0.4. Lateral friction will be 0.15. This is to be assumed because this is not given. They have given that lateral friction is assumed to develop fully. What is that lateral friction as per IRC? 0.15 you need to take. So we need to calculate required super elevation. As a ratio we need to calculate. By looking at the multiple choice, you can identify that the super elevation must be taken as a ratio. You take the general equation of super elevation. So the rate of super elevation plus lateral friction will be resisting our centrifugal ratio V square by GR. And small v is in meter per second. If you have the formula with the kmph directly, you can use it, V square by 127R. Capital V is in kmph, small v is in meter per second. For gate point of view, as virtual calculator is allowed, no need to use this and unnecessarily get confused. You can use this also. But 80 kmph you need to convert into meter per second by multiplying with 5 by 18, that you know. But however, I will substitute here, you substitute in this. So the super elevation, what is the friction given? Not given, we have assumed it as 0.15. I will take this capital V directly. Use your virtual calculator and then find out what is radius. Radius is also given, na? 250 meter is radius. Just to substitute and find out what is the super elevation required for that condition. Radius is 250 meter. So what is super elevation and which option is matching? Okay, most of the people are saying that option C, C, C. Let us see. You are saying C, let us see. 0.05, correct. 0.52 will come, you can round it to 0.05, the nearest option. So simple question only, for this to solve, you require, very good, so many people answered it, good, good, good. Okay, so you can pick up the option as option C, a straightforward memory oriented question. Especially to target good marks, and if you want to score around 50 to 60 marks out of 100, simple main questions you just go through and then hit the target. And if you are aiming for 90 plus out of 100, then you need to go for rigorous preparation, nook and corners you need to touch. If your target is somewhere around 50 to 60 marks or 65, 70 also, the basic fundamental things you rut and then practice well, go for the exam, definitely you will get that particular range of marks. If you want to target something more than that, beyond that, you need to go for nook and corners. What some people will do is, they may not have proper strategy, but they'll focus on 90 plus marks. Finally, they could not able to even qualify in the exam. So you first assess your level initially, what is your level and what is your fundamental strategy, fundamentals at present you need to assess yourself, honestly you assess, based on that target it. Okay? Just look at this question, is also a simple question based on the gradients. The correct order of descending order they are asking, decreasing order of the steepness of the camber they are asking. What is camber? Camber is a cross slope, that is to drain away the water, and you know that superior road, good quality road, superior road, we require less camber. Superior quality road can drain away the water very easily without much of trouble. So superior quality road requires less camber. Among this, which is superior most? As you know, cement concrete is superior, it should be given as rank 1. You need to descending order, na descending means high to low. Higher value first and low value next. So cement concrete is superior most. Which is the inferior among all? WBM, BT is there, gravel is inferior among all. This is inferior. So inferior should have highest of all. So you need to start with 4. The options, in the options, the first should be 4. That means C is gone, Delhi also gone, 2 options gone. We have the tug of war between option A and option B. After gravel, next inferior is WBM. So after 4, 1 should come. Okay, here 4, here 1, here 4, here also 1. So we can't pick up the answer. Next go for the other. After WBM, BT will come and superior most is CC. Next 3 should come. Next 3 should come means here next 2 is there. 2 is there means you can eliminate option A and available option is option B. Like that, go by process of elimination. No need to by heart the camber values for answering this. If you have little idea on this point, you can pick up the answer. So like that, you prepare for exam. Okay. Most of the people, yes. Answer is given as Bombay. Harish, Anand, Ajay. Okay, all the people given Bombay only. Yes. We will move to the next. This is also a fundamental oriented, actually mechanics oriented question. Look at the question. Such questions are very common in ESC. Maybe a chance of such question in GATE exam also. You require linear equations, linear motion equations for solving these problems. Look at the question, read the question. A vehicle was stopped in 2 seconds. A vehicle stopped in 2 seconds by fully jamming the brakes. By full pressing of the brake, vehicle stopped in 2 seconds. The skid marks measured 9.8 meters. The skid marks. So the distance skidded on the road is 9.8 meter. The average skid resistance coefficient. The average skid resisting coefficient is F. Coefficient of longitudinal friction or linear friction that they are asking you. So what's happening is you are going by a car. Assume that you are going by a bench car. You suddenly stopped it. Sudden application of brake is done. So the vehicle skidded for 9.8 meter. The skid distance is 9.8 meter and finally it has stopped. Final velocity is 0. What is the time of travel? 2 seconds. Initial velocity I don't know. It is not given. Not required also. But you require the quotient of longitudinal friction. You know that quotient of longitudinal friction is equal to retardation by acceleration due to gravity. A by G is quotient of longitudinal friction. A is retardation. Once you apply the brake, the velocity decreases. Rate of decrease of velocity is retardation. Rate of increase of velocity is acceleration. So here retardation comes after the application of brake. You use the first linear motion equation to relate V and U. So the final velocity V is equal to U plus AT, that you know. Final velocity is 0 because vehicle stopped. The vehicle was stopped after the application of brake. It is given. Vehicle was stopped. So final velocity is given to us. U I don't know. Acceleration also I don't know. But it stopped in 2 seconds. Initial speed is equal to minus 2a. Okay, from this equation. Now you can use any other linear motion equation so that I can make use of displacement, nothing but skid. I want the retardation finally. Shall I use S is equal to ut plus half at square? You can use it. Otherwise, if you want, you can use v square minus u square is equal to 2as also. Any one. All are with linear motion derived equations, you should get the same answer. Whether you use s is equal to ut plus half at square or v square minus u square is equal to 2as, you should get the same answer. What is final velocity? That you know, 0. Initial velocity I am substituting it as minus 2a whole square 2as. What is this s? 9.8 meter. Now you can simplify and find out what is retardation. So 2a square, 1a gets cancelled, 4a minus of minus 4a, 4a is equal to 2s. Is it s by 2? 9.8 by 2. Is it correct? Check up. Yes. Now what is f then? F is equal to a by g. G is 9.81 or 9.8 you take it. 9.8 by 2 into 9.8 you take it. 9.8, 9.8 gone. 1 by 2, 0.5 comes into the picture. Don't simplify on your own. As virtual calculator is available, make use of it. Because in the manual calculation sometimes we will commit mistake, especially in tension. Tension creates cracks. Exam tension creates cracks in the brain. That reduces your mark level, rank level, score level. So what is the answer here? So option is 0.5, you can pick it up. Okay, please. Yes. Abhijit, Vishal, Ajay, PM, so many people give an answer. Very good, very good, very good. Bombay, Bombay, Bombay. Yes, Bombay. This was a memory oriented question given in GATE previously. I have given this here because don't unnecessarily get panicked by this question. If such questions are coming, don't unnecessarily get panic in the exam hall. They'll give you some critical questions in the middle of the exam so as to decrease your confidence level. Once you are stable minded fellow, you leave the question and go to the next question. And something slightly fluctuating brain, fluctuating mind people will look at the question, get panic, their confidence level will go down by 20%. So for that, they'll give you such memory oriented critical questions. That is what generally the question setters target on the students. Because question setters also once upon a time students, they have come through all your stages and gone to that particular level of setting question papers. They know your feelings, they know your mental condition in the exam hall. That's why they'll put. Something like bouncers in the cricket, they'll put some questions. A great cricket player like Kohli and all, if bouncer comes, what they'll do? They'll leave the ball and go for the next ball. If you touch a bouncer, there may be chance of caught behind or hit wicket. So be careful about such things. They'll give you such questions because you are not, there is no need for you to score 100 by 100 marks in the GATE exam. Compared to the topper, you require slightly more than the topper. Even 0.25 more is also good. Like that one, it's all comparison. Compared to the other people, average people, what is your level? So based on that, you need to think while answering the questions and proceed ahead. You see, priority intersection. Even actually speaking, by the time this question appeared in the question paper, I was not aware of this. After that, I have gone through the code book and selected the answer. There is a condition. Because going through all the specifications of the code book, writing all the specifications is not a part of the real requirement. GATE exam is graduate aptitude test. It talks about your aptitude, it checks about your aptitude. If such questions are there, only the people who are working in that particular area can answer the questions. Very few people who are in research of this particular area can do it. Otherwise, People may think that there is something but can't recognize, can't recollect. Okay, don't worry about such questions. What is asked here? A priority intersection has single lane one-way traffic road crossing an undivided two-lane two-way traffic road. Two roads are crossing each other. The traffic stream speed on the single lane road is 20 kmph given, and the speed on the two lane road is 50 kmph given. Acceleration due to gravity also given. Remember, in GATE exam, they will give you almost all the data. Very rarely, very common specifications they will skip. Something like in the previous question, lateral friction was skipped. Like that, very common specifications they will skip. Otherwise, they will give you. Even acceleration due to gravity also given, you see. Is a GATE question. So, what they are asking you is, the clear side triangle has to be ensured at this intersection. The minimum length of the sides of the side triangle along the two-lane road first and the single lane road next, respectively are. Actually, there is a junction like this. This is, yes, this is in a priority intersection. In a priority intersection, vehicles are allowed to move with priority. That means there will be signals, there may be other instruments or police to control the traffic. That is why priority intersection will have priority movement of the vehicles. Now, this is a minor road. North-south road is minor road, east-west road is a major road. On the major road, this is the vehicle coming on the major road and this is the vehicle coming on the minor road. This driver should see this vehicle and this driver should see the vehicle from certain distance, so that there should not be any chance of accident here. For that, major road requires more distance. They are saying that you require a lag distance of V into T is required, with V is the design speed of that particular road, T is 8 seconds of time. This much of distance is required for this driver to reach here. And what about this minor road? For minor road, 15 meter is given. This is 15, visible? Minimum 15 meter distance is required. That means at a distance of 15 meter, this driver should see the opposite vehicle on a perpendicular road. And this driver should see the vehicle at a distance of V into 8 seconds. Then this fellow can control the vehicle and avoid the accident here. If this is 15 meter, this fellow can control and avoid the accident. That means this is one side of the triangle, this is other side of the triangle, this is diagonal. Diagonal is given by the line of sight. In this vision triangle, there should not be any sort of obstruction. There should not be any building, there should not be any compound wall, there should not be any parked vehicle, nothing. This should be clear. Then at this particular point, no chance of accident. Like that, as a designer, you need to manage it. Even by chance an obstruction recently constructed, you need to go and dismantle it. You need to go and remove it. Nothing will happen because you are acting as per the provisions. Even court of law will not say anything. You need to give notice to the people. If any illegal construction is there, you need to dismantle it. This area must be clear. This is for priority intersection where there is prioritization by signals or police or any other control. So minor road 15 meter. Who will remember, you tell me all these things. So they are asking you in the question as a priority intersection only. And they are asking you, two lane road is major road and a single lane road is minor road. What is the side of the triangle for major road, minor road? And you know, for minor road it is 15 meter, just now we have taken. No other case it is 15. On single lane minor road, The side of the triangle is 15 meter, that we know. With that you can pick up the final answer. 111 will be the design speed of major road into reaction time of 8 seconds, the lag distance. It will be there. No need to calculate and cross check. If you have the fundamental and if you could able to recollect that fundamental in the exam hall, picking up the answer is very simple, but such a sort of fundamental going through before exam is very difficult task. After the exam we have seen this question and checked various codes and picked up the answer. That is not the correct thing. Prior to the exam you should have this in your mind. Okay. So this whatever is given is for uncontrolled intersection. This is also given in IRC 66. This is okay, because uncontrolled intersection means no control, no police, no signal, nothing. So this fellow coming on this road, this vehicle is coming on this road and this vehicle is coming on the other side of the road. There should not be any sort of accident here. So for that, this fellow should have a stopping side distance of say SSD1. That SSD1 is based upon the design speed of this road. As it is V2 given, I will make it as SSD2. Road number 2, SSD2. Based upon the V2. And what about this distance? This will be SSD1. Based upon the design speed of V1. Calculate SSD2, SSD1. This is one side of the triangle, other side of the triangle, make the triangle, and this is our vision triangle. In this triangle, nothing should be there. No obstruction, no bushes, no building, even you should not park the vehicle. Even by chance looking at this space, if somebody parked a vehicle here, definitely there is a chance of accident coming here, hemorrhage coming here. You have to be very careful about this point. Okay? That's why even parking of the vehicle is also not allowed. That's why what the people do is, they'll make this area slightly rough so that even the vehicles feel reluctant to park. It should be kept always empty. They make it slightly rough. Even some small boulders they'll keep it. Or otherwise they'll grow some sort of, some sort of garden whose height may not be more than the 1.2 meter height of the driver's eyesight. Okay? So such a rare questions, don't target it. And we have three type of questions in the gate, as you know. One is multiple choice question, numerical answer question, multiple select question. The problem with the multiple choice question is there is a negative mark. 1/3 negative comes if you put wrong answer. In case of numerical answer question and multiple select question, no negative marking. That is one side of the story, happy point. In multiple select questions, recently added into the GATE exam 2021 added, but no question was there in the previous year paper. But in case of CSC and CSC, there were so many multiple select questions in their paper, recent last paper. Computer science, electronics, there was one question, but civil, no question was there. In future it may come, because this multiple select question will have 4 choice. In that 4 choice, there may be more than one correct answer. If you pick up all the correct answers, then only you will get the full marks for that, otherwise 0 marks, no chance of negative. See this, a highway, a descending gradient of 1 in 25 meets an ascending means upward, descending is downwards, 1 in 20 on a valley curve. Oh, they are talking about valley curves. Needs to be designed for a design speed of 90 kmph. The design speed is mentioned as 90. The rate of change of allowable acceleration is 0.5 meter per second cube. Is rate of change of centrifugal or radial acceleration. reaction time is given as 2.5 seconds for average driver based on PIV theory. Longitudinal quotient of friction is 0.35. Longitudinal quotient of friction, we need to use it in SSD. Height of headlight is 0.75 meter. We call it as H1. Remember, this is a valley curve, and angle of the headlight beam is 1 degree upwards. So as to cover more range of the headlight, you have even the company setting of the headlight will be 1 degree up, slightly up. Which of the following options are true? Look at what they are asking you. Length based on comfort criteria. Comfort means centrifugal criteria. Next is headlight side distance they are asking you in the second option. The third, length of valley curve based on headlight side distance. Length of valley curve based on headlight side distance. Headlight side distance is nothing but stopping side distance only. Now length based on the comfort criteria, okay, two things are given, one may be wrong. Length based on comfort criteria 106 is given in option A, 350 is given in option D, one may be correct among. You need to identify the option B and option C are correct or not. This is a valley curve. First of all, we will calculate the deflection angle of the valley curve. 1 in 25, 1 in 20. I will go to the next slide just for checking purpose. This is a valley curve. Descending is 1 in 25, minus I am taking for descending. Up is plus 1 in 20. Okay, 1 in 25, 1 in 20. You have the valley curve in the middle, like this. So what is the deflection angle? Deflection or deviation angle is G in nothing but algebraic difference of the gradients. Algebraic difference of the gradients is nothing but the first gradient along with its own sign minus of the second gradient along with its own sign. Okay? Downward is negative, upward is positive. Going up and up in life is positive, coming down is generally negative. Just casually I am saying. So if you can take out this negative says the curve is a valley curve. This negative, whatever you are taking out common, is a indication that the curve is a valley curve, and we never use that negative in the substitution in the formulae. Okay, what is this? This is 0.09, 9%, the deflection angle. Now what do you need to calculate? First I will try to calculate the headlight side distance. Headlight focus should reach to minimum of stopping side distance. So what is stopping side distance if you remember? Indirectly you require stopping side distance to solve this problem. Lengthy question, it takes more time. But available time for us, it is a 2 marks question, available time with us is 3.6 minutes. You can do it if you have good speed and if you by heart the formulae. These are not rare formulae, these are routine formulae, what we generally by heart. So if you have good speed and accuracy, you can directly get the answer without much of trouble. This is a common favorite question to all. So lag distance plus 2GF. Okay. What is the speed in meter per second? They have given in kmph. What is the speed? 90 kmph. I will convert into meter per second. Multiply with 5 by 18. What is the value? Teja. 25 meter per second. So substitute 25 is the speed. The reaction time of the driver is given to us. How much is the reaction time? 2.5 seconds of time. V square You need to use online calculator. 2 into G also given to us. Is it given? Acceleration due to gravity is not given. You assume 9.81. Quotient of friction, longitudinal friction 0.35. Simplify and give me what is HSD, nothing but SSD. Yes, yes, please. Paran Raj, 153.67. Wow. 153 point. Okay, 153 Ajay. Ajay will take 153.5. Okay. First part is over. Answer is matching, matching, matching. Yes. So, you can select more than one option, and especially in the gate, if it is a multiple select question, they will mention it on the top. Question number 34, multiple select question. Question number 23, multiple select question. Like that, they will mention it. Numerical answer question you can identify. Even multiple choice question you can identify. To make it different from multiple choice question, they will mention like this. In the question itself, they will mention it, is not a worry. If you select two options can get selected for multiple select question. In multiple choice question, if you select option A, that will be getting selected. If you afterwards if you select option B, option A selection will go away, option B gets selected. That is what generally happening. So headlight side distance first is correct, B is correct. Length based on comfort criteria will take. So what is length based on comfort criteria? Comfort or centrifugal criteria? Centrifugal force will be causing a lot of trouble on the valley curve because weight is acting down, centrifugal force is also acting down. On summit curve, centrifugal force is not a criteria. On valley curve, centrifugal force is a design criteria. We will take two cubic parabola transition curves, join them symmetrically. LS is a cubic parabola transition curve. So, two parts joined symmetrically. This is a GV cube by rate of change of acceleration under root, nothing but whole power 1 by 2. Substitute all and give me the answer. Don't forget to take 2. Don't forget to take whole power 1 by 2 or root. People may forget this multiplication of 2. Some people forget this root. Be careful. These are the common mistakes what the people are generally committing. So, speed is 25. G is 0.09. Rate of change of centrifugal acceleration given. It is 0.5 meter per second cube. For valley curve, IRC recommends to use 0.61 meter per second cube. But they have given 0.5, whatever is given you need to choose it. So 0.5 you take, root over. What is the answer please? 6. 106 correct. Mahesh, Satish, Ajay, yes. Is it matching as correct option? Comfort criteria, length based on the comfort criteria is 106. So option D is gone. Option A is a correct option. I will put it in green color, correct. Length of valley curve based on headlight side distance they are asking. So headlight side distance is also based upon HSD, nothing but SSD. So headlight side distance, HSD criteria. HSD nothing but SSD criteria. Sight distance at night. Here there are two cases. We need to assume L more than or equal to S, nothing but HSD. In most of the cases, this is the criteria which is generally suitable for us. It is the value GS square divided by 2H1, height of the headlight above road surface, 2S. S is the sight distance, nothing but HSD, tan alpha. Alpha is angle of headlight beam. Alpha is taken equal to 1 degree. What is height of the headlight over the road surface is given as 0.75 meter. And S is our HSD, whatever you have calculated, that you substitute. G is 9% gradient, 0.09. Now give me what should be the length. Let us see how many of you solved it. Oh, ABC are correct. Solanki, Raj, very good. Jerry, so this is, what is the value? 306. 308.6, okay. 309. After you calculate this L value, you need to check whether assumption is correct or not. L is 309. Is it more than S or not? L calculated is more than our S, HSD. That means assumption is correct. If by chance assumption is wrong, you need to go for the second formula and recalculate the length again. So presently assumption is okay. The HSD value, whatever you have calculated is 153.5 na? Okay, length is 309, which is more than 153.5. Assumption is correct. You can pick up the answer as, which is correct option? So 309, this is also correct option. So answer is A, B, C are correct. Delhi Khan. You can select the three options. Time taking question. Okay. We'll move to the next. Time is almost 6:57. Look at the question. I'll just give you the procedure. A horizontal circle. This is based on the setback distance. This is based upon the setback. Okay. A horizontal circular curve which has a center line radius. Radius is always taken up to the center line of the road only. If radius is 200 meter, that is from the center of the radius to the center of the entire road. Radius, if somebody says radius, it is center of the entire road only. On a two-lane, two-way highway it is given. Two-lane, two-way is a two-lane road. What is the width of the road is also given as 7 meter. The safe stopping side distance is given as 125 meter. The setback is to be designed to satisfy safe SSD. It is mentioned. Actually, two-lane, two-way road, overtaking is also allowed. But they wanted to design the setback only based upon the SSD. If you don't read this line, whatever is underlined with red color, you miss the answer. It's a two-lane road, overtaking is allowed, but they don't want to allow overtaking side distance. They wanted to calculate the setback distance, nothing but the distance of the obstruction on the inner side of the curve based upon the safe SSD. Okay. Safe SSD value is also directly given to you. The setback distance from the center line of the inner lane they are asking. This point is also slightly crucial. I will underline with greening. From the center line of the inner lane they are asking. We will check up. We will go to the next slide. 2-lane road like this. Actually, in the calculation of setback, the setback distance is measured from the center line of entire road to the inner side obstruction. Center line of entire road to the inner side obstruction is our setback. All the parameters will take from the center line of entire road only. That point you try to remember it. But the critical vehicle is close to the obstruction which is passing through the center line of the inner lane. The critical vehicle is passing through the center line of inner lane. Radius of the curve, setback distance, everything taken from the center line of entire road, but critical vehicle is passing through the center line of the inner lane. The distance between the two, we will call it as small d. Small d. How much is small d value? Total width of the road is 7 meter, that is nothing but here 3.5, here also 3.5 meter. So small d is 3.5 by 2, nothing but 1.75 meter. First of all, the setback distance we need to assume, if nothing is specified, we always assume L is more than or equal to S is equal to presently safe SSD. How much is the safe SSD now taken? 125 meter. Assume L more than or equal to S. That's what we generally start. So setback distance for multi-lane road is R minus D you need to take. Remember this? Cos alpha by 2. This setback distance is from the center line of entire road to the inner side of the obstruction. Now alpha, how do you calculate alpha? Alpha is based upon the arc length. Arc length is the side distance is equal to R minus D, because the side distance is for the critical vehicle which is moving on the center line of inner lane. So arc length has a radius of R minus D and we require arc length is equal to the side distance, the safe side distance, R minus D into alpha. Here alpha is a direct angle. Direct angle generally comes in radian. That's why we need to convert this into degree. Because here you need to substitute alpha in terms of degree only, because you are using it in trigonometrical term. While substituting in trigonometrical terms, we require to substitute that angle in degree. Direct angle generally comes in radian. That is a point you know already. Substitute and tell me what is alpha. Alpha value, somebody please help. Answer you are given. So alpha is 36.12. Now substitute everything. What is the radius? Radius is 200 meter. 200 minus D. 1.75 cos of alpha by 2, 36.12. So this is the setback taken from center line of entire road to the inner side obstruction. What is the value please? Yes, 36.12 is alpha. Prasad correct, Nagsai correct, Ajay correct, Jerry correct, very good. Now what is this M value? 11.5, 11.52. But what they are asking you in the question is, that is a twist in the gate question. They are asking you setback distance from the center line of the inner lane. Whatever you calculate is directly from the center line of entire road, but they are asking you this distance, m dash distance. So from the center line of inner lane to inner side obstruction is m dash, that will be m minus d, 11.52 minus 1.75. If you are not reading the question carefully, there is a chance of committing mistake like this. Around 20 to 30% of the people, they calculate m and substitute that as an answer. But actually that is not the correct answer. M minus d is the correct answer. That's what we require to substitute. So what is m minus d? Yes, very good. 9.76. This is the way we need to solve the questions. In gate question, if you are not reading the question properly, gone onto the negative if it is a multiple choice question. Otherwise, you can touch 0. Payment design, 1 or 3 marks, not more than that. Not so critical and important. We have flexible payments and rigid payment, and targeting questions here will be easy. In flexible payments, they are asking you mainly the vehicle damage factor calculation. Vehicle damage factor, otherwise convert everything into standard axles. Vehicle damage factor or number of standard axles. What is standard axle? The rear axle of a lorry, we treat it as a standard axle. Rear axle of a normal lorry will have left 2 tires, right 2 tires, MRF connected by axle. So dual wheel single axle is the standard axle. What is the load acting on that? As per IRC 2018 version, IRC code point of view, IRC 37 2018 version, 80 kilonewton is the standard axle load we'll consider. We need to convert everything into standard axles. We count the traffic on the road, we'll take all commercial vehicles. Commercial vehicle is nothing but the laden weight more than 3 tons. Laden weight means dead load plus live load more than 3 ton, we call it as a commercial vehicle that can damage the road. That's why we consider only commercial vehicles in the design of payment. Car, cycle, rickshaw, auto we don't consider because they won't damage. Lighter loads won't damage the road. I'll show you. So after the vehicle damage factor, people ask you to, there may be chance of asking cumulative standard axles, CSA. Cumulative standard axles in the life of the payment. We need to forecast, we need to estimate by the formula. On this formula, almost every year question is coming up. By chance if question is missing in a particular year, next year definitely comes. You remember that formula? 365 days of a year divided by R, probability based formula, 1 plus R power n minus 1 into the traffic at the end of construction is A in terms of CVPD, commercial vehicle per day, lane distribution factor, vehicle damage factor. So vehicle damage factor calculation is important. That vehicle damage factor we'll use it in the cumulative standard axles in the life of the payment. A is the traffic at the end of the life of, at the end of the construction, not at the end of the life. A is commercial vehicles per day at the end of construction, nothing but beginning of the life. D is the distribution factor. The distribution factor gives you traffic on a critical lane if the total traffic is known to you. The lane distribution factors you need to by heart because sometimes in question lane distribution factor values they may not give you, you need to by heart it. There is a table in IRC, you might have come across that, but next is, that's all. This is what generally asked in flexible payment design. Very commonly asked areas to calculate cumulative standard axles, and gate point of view very important. Now coming to the rigid payment design, I will go to the next slide for rigid pavement design. In the rigid pavement design, we have various wheel load stresses, interior, edge and corner stresses. That formulae nobody will ask you. I don't think so questions will come on Westergaard wheel load formulae. Even modified Westergaard wheel load formulae, whatever you are using in IRC 57 2015 version, nobody will ask you. Even Bradbury warping formulae are there na? That also nobody will ask you. I am thinking that not so important. Frictional stress calculation they may ask you. We have load stress, warping, friction. The frictional stress calculation you just go through, because that is based upon logic, that is based upon equating frictional force is equal to resisting force. So, frictional stress generally comes because of seasonal variation of temperature. Warping is because of daily variation of temperature. So, frictional stress calculation is important for us. Apart from that, the load combinations, critical load combinations. There is a chance of question on this, because you can solve the problems on critical load combination within specified time. Three critical combinations are given in IRC. One is summer midday edge region, next is winter midday edge region, next is winter midnight corner region. Summer and winter is to relate the frictional stress, midday and midnight related to warping, daily variation of temperature in a day or temperature gradient across the thickness of the pavement is creating the warping. And the wheel load stress is very common. We have three critical combinations. Interior is always safe, that we don't use it in the critical combinations. We have only edge and corner. Okay. So, daytime edge is critical, nighttime corner is critical, warping point of view. Next, after that, expansion joint spacing, very similar to whatever you use in strength of material. Change in length is equal to L alpha delta T, but change in length is taken equal to the gap by 2 at the expansion joint, because at the gap of expansion joint we use filler material, and that filler material is nothing but mastic pad, which allows only 50% of the gap for the pavement to expand, remaining 50% it occupies. Okay, that you know. Next is the contraction joint spacing, also important for us. Contraction joint spacing in plain cement concrete and reinforced cement concrete also. Next is dowel bar. Especially the load carried by critical dowel bar they will ask you, not the entire dowel bar design. Dowel bar is provided at the expansion joint. Next is the tie bar. In tie bar they will ask you the spacing as well length of the tie bar. So, these are the important areas on which you need to concentrate for GATE exam. In ESC exam and other exams they can ask you from any corner because the theory parts, but GATE point of view these are the important things in my point of view. Okay. And be careful about theory questions which may come on the warping temperature stresses. We will just check up 1 or 2 questions on this pavement design. You can look at this, a theory based question. As per IRC 37 2012, presently 2018 version is also there in the market. Once new version comes, old version goes outdated. In order to control the subgrade rutting, rut2, the rutting in the flexible pavement, the parameter to be considered are, especially there are 2 serviceability or performance criteria. Load criteria is collapse criteria, like what you use in limit state method. The serviceability criteria or performance criteria are rut, fatigue. Rut is nothing but longitudinal grooves on the road surface. Longitudinal grooves on the road surface or rutting is because of consolidation of subgrade soil. Subgrade is lowermost natural soil na, that slowly consolidates under moisture. The vertical compressive strain of the subgrade is considered in the rutting process. We calculate standard axles to create 20 mm depth of rut. You remember? So for that, vertical compressive strain on the top of subgrade we use. Rutting criteria uses vertical compressive strain on the top of the subgrade. Fatigue criteria? Fatigue criteria uses tensile strain on the bottom bituminous layer. If you have 2-3 bituminous layers like binding cores, the topmost wearing cores and all, you need to consider bottom bituminous layer on the bottom side. There may be chance of tension that creates the crack. So rutting is based upon compressive strain on the top of the subgrade. Fatigue is based upon the tensile strain on the bottom of the bottom bituminous layer, that you know already. So that formulae of rutting, formula of fatigue are very critical formulae. Don't even look at that formulae. Don't even touch to by heart it. After the exam, if you want, you can by heart, not before the exam. By chance question comes from that area, leave it. Impossible to by heart. Even though you by heart it today, within 2-3 hours you will forget. There is a problem with such critical formulae. You might have come across this fatigue cracks. Because of repeated wheel loads, you see micro cracks. Such cracks you can get it on the skin also during winter, micro cracks. And rutting is the longitudinal grooves. This is because of the consolidation of the subgrade soil. So rutting and fatigue comes under performance or serviceability criteria. Because the flexible pavement design, whatever you are using is mechanistic empirical approach, and we are using modified CBR method. You see this. Number of commercial vehicles on a highway are given as follows. All are commercial vehicles. What is a commercial vehicle? The total load, laden weight more than 3 ton is a commercial vehicle. You have 100 buses with the front axle 40 kilonewton and rear axle 80 kilonewton. 200 lorries or trucks with the front axle load 50 kilonewton and rear 90 kilonewton. What they are asking you, calculate total number of standard axles in terms of standard axle load of 80, including front as well rear. As per our IRC is concerned, we ignore the front axles, but here we are asked to consider front axle as well rear axle. As per our IRC design of flexible pavement is concerned, front axle load is very less, we ignore it, we take only rear axle loads. But here we need to consider front axle as well rear axle. So how do you convert everything into the standard axle? Based on equivalency factor. What is equivalency factor? Equivalent axle load factor. Equivalent axle load factor or equivalency factor, both are the same. Equivalent axle load factor or equivalency factor, both are the same. This is nothing but actual axle load by the standard axle load power 4 based on the 4th power rule. Don't ask me how it has come, it is based upon empirical approach, it is specified in the code book. So total number of standard axles. Total number of standard axles. Standard axle means each axle will have a load of 80 kilonewton. You have 100 buses. What about the front axle? 100 front axles will be there. Each weight is 40 kilonewton. Actual load is 40, standard is 80. Power 4. So this gives you the total axles in terms of 80 kilonewton. Actually 100 front axles are there, multiply with the equivalent axle load factor, this total gives you the number of axles in terms of standard axle of 80 kilonewton. Next, bus rear axle will take 100 buses, rear axle load of the bus is given as how much? 80 kilonewton. Actual is 80, standard also 80. I will tell you this without calculator. I can tell you without calculator. So now come to the lorries. 200 lorries, front axle 50 kilonewton. 200 lorries, front axle 50 kilonewton, but standard is 80. Make it with power 4. This converts the 200 front axles of the lorry into standard 80 kilonewton axles. What about rear axle of the lorry? 200 rear axles of the lorry, 90 is the actual, 80 is the standard. This is more than the standard. You take them separately, add them separately, then we will get the answer. So, what is the answer here? Answer. This will be 6.25, okay. You see, even though 100 axles of 40 kilonewton, which is equivalent to 6.25 axles of 80 kilonewton. That's why IRC ignores the front axles. They will consider only rear axles, and that rear axles will convert into 80 kilonewton standard axle load. So this is 6.25, next is directly 100, next is 30.5, next is 320.36. Total sum you take it up. Sum of all will be 457. Very good, 457.13. Standard axles. So in this group, we have 457 standard axles. That's it. 457 axles are there. What is the load acting on each and every axle? 80 kilonewton. 80 kilonewton nothing but sometimes people say it as 8 tons. 1 ton is 10 kilonewton. Okay. Sometimes based on this they will ask you vehicle damage factor. Vehicle damage factor is nothing but the damaging capacity of a group of vehicles compared to a vehicle with standard axle load. How do you calculate this? N1 number of vehicles with damaging factor F1, N2, F2, like that, so on and so forth, divided by all the number of vehicles, so on and so forth. Can you calculate vehicle damage factor of the previous example? In the previous example, we have a group of vehicles, 100 buses and 200 lorries. So, equivalency factor N1 F1, N2 F2, N3 F3, N4 F4 is given by 457. Okay na? The numerator is given by 457 for the previous example. Total number of axles we have considered, total actual axles, 100 buses, front axle, rear axle also they are asking us to consider. Na? So 200 axles of buses, 200 plus 200, 400, 400 plus 200, 600 divided by 600. This is a vehicle damage factor. You may get less than 1. Less than 1 means the damaging capacity of the group of the vehicles, whatever is given in the question, are creating less damage than that of vehicle with standard axle load. Standard axle load is 80. Vehicle damage factor less than 1 means it is damaging less than the standard. Vehicle damage factor more than 1 means it is damaging more than the standard. Based on the damaging capacity, we design the flexible payments. Okay, Ajit? 0.762, very correct. Okay, okay, okay. This is based upon the cumulative standard axial loads. They are asking you to calculate the cumulative standard axials. Such a question is coming every year almost, every time almost. There are two axial trucks and tandem axial trucks. Two axial truck is a small lorry. Tandem axial truck the two axial truck may be like this, two axles. This is tandem axial truck is a big lorry. You have two axles very close to each other on the back side. So this is this, this is this. This is a heavy lorry, that's why it is having more vehicle damage factor, less vehicle damage factor. 2000 two axial trucks are there, 200 tandem axial trucks are there. They have given the growth rate as a 7.5% and cumulative number of standard axles they are asking you to calculate in million. Life of the pavement is 10 years. So you have two categories of the vehicles. So cumulative standard axles can be 365 by rate of growth of commercial traffic, 1 plus rate of growth of commercial traffic, power life of the pavement minus 1, A1, D1, F1. Two categories are there, A2, D2, F2. So substitute all as per the data, we will get the answer. But based on this formula, what is the rate of growth given for us? 7.5%, but you need to use it as a ratio. 7.5% means 0.075. Use it as a ratio. 0.075. Life of the pavement is given as 10. What about A1, D1? A1, D1 nothing but number of vehicles multiplied with distribution factor. Actually in the second column of the table, whatever they have given is vehicles considering the number of lanes. Have you observed this? Vehicles considering number of lanes. That means this 2000 is A1, D1, 200 is A2, D2. Directly after multiplying with distribution factor, the values are given. This is A1, D1. This is A2. After multiplying with the distribution factor, vehicles are given. This is F1, vehicle damage factor of two axle trucks. This is a vehicle damage factor of tandem axle truck. So 2000 into 5, 200 into 6. 2000 into 5 plus 200 into 6. This 2000 is A1, D1 together. 200 is A2, D2 together. You can give me the answer, please. Achha, options are there. Bombay, Bombay, Bombay people are given. Are you are so fans of Bombay? 57.8 million standard axles are coming. Okay, this may be 57.8 into 10 power 6 cumulative standard axles. So 57.8 millions of standard axles. Million is 10 power 6. So this many millions of standard axles can move on the pavement in a life period of 10 years. That's what we expect, and then we design the pavement. Okay, please. Critical combination of stresses. Questions may come on this. See this question and tell me the answer. Let us see how many of you tell me the answer directly. Time is ticking up. 7:32. So the load stress is given, warping stress is given, frictional stresses are given. This is load stress, warping stress, frictional stress. They are asking you critical combination of the stresses during summer midday. So critical stress is equal to stress due to wheel load plus stress due to warping And summer midday na, summer friction is compressive. Here you are taking positive for tension, negative for compression. Frictional stress is compressive in summer. Winter it is tensile. So wheel load stress is 210, 290 minus 10. 270 plus 280 plus 210, 490. Answer is there. Newton per mm square, megapascal. Like that, if you know the formulae, straightforward. If you want to get 50 to 60 marks, only to the point formula oriented questions you practice. If you are not getting 60 marks, you ask me. If you want to score more than that, you need very rigorous strategic preparation. Okay? So, for average people, what I mean to say is, just go through the standard cases, standard answers, standard way you practice, you get the answer. You get 50 to 60% of the marks out of 100. Okay? So, if you just qualify also, you can join MTech with stipend. That is the speciality of GATE exam. Okay? In a concrete pavement near edge or interior, theory based question, slightly critical, sometimes confusing also. Give me the answer. In a concrete pavement near edge, they are asking you near edge or interior. Interior and edge both are having same nature of stress, no need to worry about it. So, temperature stress is tensile at bottom during daytime. If they are asking you day and night, it is nothing but warping stress. Day-night variation is warping stress. Summer-winter variation is frictional stress. So, load stress is compressive at bottom. Actually, daytime na, tensile. During daytime, top surface temperature is high. Top surface temperature is high, top layer expands more. So, during the daytime, sunlight will be there. And it wanted to warp like this, but the self weight stops it. The self weight prevents this warping. It wanted to warp, but self weight stops. That's why on the interior and edge, we'll get tension on bottom. Interior and edge cases, tension will develop on the bottom during daytime. So, temperature stress is tensile at the bottom during daytime. So, the first statement is true. Regarding the second statement, load stress is compressive at bottom. Load stress means this is the pavement, this is the wheel load. Wheel load is acting at the interior or edge. Because of the wheel load is direct load. Directly you will get tension on the bottom. Wheel load stress, warping stress will be of the same nature. Here why the stress is coming? As you prevent the warping, stress is coming. This is direct load. Temperature stresses are indirect stresses. If you prevent free movement or free warping, we get stress. So, during daytime, you get tension on the bottom of the edge or interior. Due to wheel load, you will get tension on the bottom of edge or interior. So, load stresses are compressive at bottom. So, this is a false statement. False statement. What may be the answer for us? Anybody given it? Yes, Bombay, Bombay, Bombay. Diya Bombay, Anusha Bombay, PM Bombay, Sachin Bombay. Okay, very good, very good, very good. You are all strong in fundamentals. You are strong in transportation. Simple subject. Easy to score, easy to get marks with little practice. So, concentrate. Design of dowel bar. The critical dowel bars we provide at the expansion joint, fixed at one end, free at the other end. A simple question to find out the load on the critical dowel bar. I am not going to solve this. These are the dowel bars which are kept on the longitudinal, kept at the expansion joint. This is a longitudinal joint. This is a critical dowel. Once the wheel load is at the critical dowel is near to the edge. What happens is the load distributes to some length. So this dowel is subjected to maximum load, next dowel is subjected to lesser. So in this may be usually taken as radius of relative stiffness. So this wheel load, 40% of the wheel load will go on to this dowel group. So this question, a similar question was there in the previous gate, just to solve it once. This type of questions are important. As I am falling short of time, I am leaving this question, but go through this. This is also a question on the tie bars. Question on the tie bar. Where do you provide tie bar? Tie bars are provided at the longitudinal joints. Tie bars are provided along the longitudinal joints. Is a tension member. Tie is a tension member fixed at both ends. What is given here? A rigid pavement is to be designated with thickness of 20 centimeter. H is 20 centimeter. Density of the concrete is given 2400 kg per meter cube. Width of the pavement is given 3.5 meter. The quotient of friction between PCC road and soil is 1.5. Actually, the pavement is directly resting on the soil, friction is very high. To reduce the friction, we are putting the polythene sheet. We place a polythene sheet on the soil and then we pour the concrete to reduce the friction. With that, we reduce friction by a little, not too high. The allowable tensile strength of the concrete is given as 0.8 kg per centimeter square. The spacing of the contraction joint rounded to 1 decimal point they are asking you. You can simply substitute in the equation. Frictional force is equal to resisting force. Quotient of friction into density of concrete into width into thickness into length by 2. Who is resisting this? The tensile strength of the concrete, and the cross section, critical cross section is B into H. Substitute all and find out what is L here. Just be careful with units. I will substitute in a different way so that I will keep the same units on the left side and right side. Gamma C density of concrete is 2400 kg per meter cube. I am keeping as it is. Width I will keep it in meter. How much is width? 3.5 meter. Thickness 20 centimeter. I will keep it in meter. L length will also be in meter by 2. Derivation of this formula you need to go through, because without deriving you have to be in a position to put the formula without much of thinking. Like that you need to practice it. Practice makes everybody perfect. What is the tensile strength of the concrete? 0.8 kg per centimeter square. This is kg per centimeter square. Width I will substitute in centimeter, nothing but 350 centimeter. Thickness also I will substitute in centimeter. The fancy of this thing is, right side what is the unit? Resultant unit, kg per centimeter square into centimeter into centimeter. Left side unit is directly kg. What is right side unit? Kg per meter cube, meter into meter into meter is also kg. Left kg, right kg, finally we will get length in meter. Simplify, tell me the answer. Yes, I will upload the PDF. Sachin, 4.44, yes. 4.44 meter. Rounded to 1 decimal place. What to do now? You have given me 2 decimal places, Sachin. Paranraj also rounded to 2 decimal places. Round it to 1. As the last is less than 5, so you can keep it 4.4 meter. By chance it is 5 or more than 5. This decimal is more than 5 or equal to 5. Add 1 to the previous. So presently 4.44, we round it to 4.4 directly. Okay, okay? Okay. So traffic engineering will be causing a little traffic jam. There is a chance of every now and then one new question coming into the picture, because most of you might have studied traffic in a limited manner in your curriculum. But the people who are setting the paper are experts. And those experts will be thinking that critical concepts for us may be easier concepts for them. So every now and then they are bringing a new question, one bouncer from the traffic. Be careful about it. We can't do, because we can't research on the traffic and prepare, but within our limitations, be cautious to prepare. Don't leave the things, be cautious to prepare based upon the previous year questions and all. We can't do much. Beyond the previous year questions and beyond the syllabus, if you prepare, sometimes it may be waste of time. And sometimes it may be causing tension in brain. Maybe a chance of, mentally you prepare that there may be a chance of one bouncer from the traffic that creates the traffic jam. So minimum 4 marks are coming from the traffic. You see, very good area. Because if you go to any IITs, there are 2 streams. One is design stream and the other is traffic analysis stream. And usually IIT Mumbai people are very strong in traffic analysis, and payment design point of view Kharagpur. No alternative for that. So people will be sharing the total transportation into 2 equal parts, the geometric design and payment design and all one part, the traffic at the other part. That's why they are giving you almost equivalent weightage to the rest of the part of the syllabus. 4 marks almost. Be careful about the basic traffic parameters like traffic volume, traffic density and speed. In traffic volume, peak hour factors, very commonly people are asking nowadays. Calculation of peak hour factors. Concentrate more on the peak hour factor. Okay? And coming to the speed analysis, in the speed analysis, there is a chance of spot speeds. They may ask you to calculate time mean speed and space mean speeds. Time mean speed is a direct mean, space mean speed is a harmonic mean of the spot speeds. This is an important area. Next is the time headway. Time headway is time gap between the 2 successive vehicles. It is nothing but reciprocal of traffic flow. And space headway is nothing but space gap between the 2 successive vehicles. It is nothing but reciprocal of density, traffic density. So traffic density is number of vehicles per kilometer length. Space headway is kilometer of distance between one vehicle to another vehicle. Time headway is reciprocal of traffic flow, nothing but Q. Q is vehicle per hour and the time headway is hour per vehicle. If you want, you can convert into second per vehicle or minute per vehicle also. So these 2 are microscopic parameters, and Q, K and V are macroscopic, big parameters. So concentrate on peak hour factor, concentrate on space mean speed, time mean speed. And afterwards, you have to be very careful about linear speed density relation given by green shield model. Almost every alternate year, question is coming from green shield model. If question is coming in the morning session, afternoon session they may not get it. They'll give you question on traffic signals. If a question is not coming on traffic signal, they'll give a question on this. If question is not coming on the green shield, there may be chance of signal problem. So, very easy to predict questions. Important and routine questions you can predict. I told you there is a chance of one bouncer from traffic. Next is signal design. Optimum cycle length, very commonly asked by Webster, and Webster's delay. Nowadays, without much of delay, they are asking questions on this Webster's delay also. Either you can use graphical approach or the formula. But anything, you should be in a position to solve the problem very quickly. Webster's delay is very important, and Webster's cycle length calculation is slightly less important. But questions are repeatedly coming on this. So either question may come on signal or question may come on green shield approach, linear speed density approach. Look at the questions. Spot speed studies yield the following: frequency distribution table. They are asking you time mean speed and space mean speed. Time mean speed is direct mean of all spot speeds that you know. How do you calculate direct mean of all spot speeds? This is a table given. 2.5 meter per second one vehicle, 7.5 meter per second 4 vehicles, 11.50, 15.5 7 vehicles. So the average options are there. Yes, options are there. Time mean speed is 2.5 into 1 vehicle, 7.54 vehicles plus 11.50 vehicles, 15.57 vehicles divided by total number of vehicles. Direct mean 1 plus 4 plus 0 plus 7. Somebody please give me. Yes, Paran Raj. Green shield model is as you told. Shockwave equation, Sunny, there may be a chance of one question previously asked. Shockwave may come because of sudden application of a brake of a vehicle in a traffic stream. So shockwave is indicated by increase in density and decrease in speed. If the density is increasing and speed of the vehicles reducing, is a shock wave. Shock wave may come because of sudden application of brake of a vehicle while moving in a stream, or otherwise sudden reduction of the width of the road will give you the shock wave. 11.75. Is there any chance to pick up the answer directly without calculating the space mean speed? You see 11.75, only one option is there. With 11.75 you can pick it up. Actually speaking, the time mean speed is more than space mean speed. Always time mean speed value is more than the space mean speed. That point also you need to remember. This is time mean speed is higher than the space mean speed. Okay. But here also nearly 11.23, but this is exactly matching. Option A is exactly matching. Go with option A. If you pick up the answer only with the time mean speed, you can save time. Sometimes you need to use the logic to reduce your workload. This is also multiple select question. Try this please. Green shield model. (752) just. On a road with a linear speed density means green shield model. Speed is 65 kmph. Speed headway at jam condition is 6.25. Space headway. Which of the following statements are correct? Maximum flow they are asking, Qmax. Qmax is nothing but maximum speed by 2, maximum density by 2. What is speed? 65 by 2. The Kmax is actually space headway is given. Kmax is 1000 by space headway. Space headway meter per vehicle. So this can be 1000 by space headway 6.25 meter between one vehicle to one vehicle by 2. Simplify this. 6.25 meter per vehicle. If you want to convert this into kilometer per vehicle, what do you need to do? 6.25 by 1000 kilometer per vehicle. Reverse it. That is density. Reciprocal of space headway is our density. So what is the answer? ABC are answers. Siddhant is very fast. Durgesh is saying ABCD are correct. Let us see. So is it 2600 vehicle per hour? Okay. Option A is correct. Maximum flow occurs at a speed of 32.5 kilometer per hour. Maximum density, is it 160 vehicle per kilometer? This Kmax. Kmax is 1000 by 6.25. 1000 by 6.25 is 160 vehicle per kilometer. Okay, correct. That means C is also correct. Maximum flow occurs at a speed of Vmax by 2. 65 by 2, nothing but 32.5. Flow occurs at a density of maximum flow, Qmax occurs at a density of 160 by 2. This is also correct. Yes. Ashok, correct. All are correct, Prasad. Perfect, perfect, perfect. So this is, I'll upload this PDF. You can try to solve it. This is based upon the Webster's cycle time. C0 is 1.5, last time plus 5, 1 minus y. Last time per cycle. And y is the sum of normal flow to saturation flows of various phases. Okay. Here you will get answer as 77. Solve it later, but concentrate on Webster's cycle time calculation. The highway material and testing, theoretical questions will come from this area. So you may get 1 or 3 marks. Most probably 1 or 2 marks I can say. Here you need to concentrate on aim of the experiment, apparatus used, and simple specifications. That's enough. No need to go through the stepwise procedure of each and every experiment for gate point of view. And you can classify the highway material and testing into subgrade properties, all subgrade properties. We will talk about CBR and modulus of subgrade reaction. CBR is done by CBR test. Modulus of subgrade reaction K can be calculated by plate bearing or plate load test. Next is aggregate properties. Like toughness, hardness, strength, next specific gravity, water absorption, all the aggregate properties you need to go through. The experiment whatever you want to conduct and the specifications as per IRC code. Next is bituminous properties, bit2 properties. Bitumen properties like softening point, the viscosity test, and various other tests, ring ball test, the flash point, fire point test, all the tests you need to go through, aim, apparatus and specifications as per IRC. And afterwards, bituminous concrete mix, bituminous concrete mix design, Marshall. Marshall method of test you need to go through, especially the calculation of theoretical specific gravity, the bulk specific gravity, voids in mineral aggregate, voids filled by the aggregate, voids filled by the bitumen. These things you need to concentrate. So in highway material and testing, Marshall mix design, especially the calculation of voids filled with bitumen and voids in mineral aggregate, these calculations are very important. Every now and then questions are coming. See the previous year questions of the previous GATE exam and then try to concentrate on this. Because of the time problem, I am not going into the details of this. So this is highway material and testing. Simple questions may come from the highway material and testing. This is what do you say, the based upon the CBR test. So concentrate well. Apart from this, you have airport. In the airport only two things are there. Airport engineering, we have to concentrate only two parts. One is runway length corrections, length calculations and corrections of runway. Length is calculated based on normal landing, normal takeoff, emergency stop conditions. In normal conditions, we consider normal landing, normal takeoff, emergency stop. Among the three, we will pick up the maximum. And after that, we will go for the corrections. What are the corrections? Elevation correction. Next is temperature correction. Sequence is important. Third one is gradient correction. Very, very important for us. And afterwards, we need to go for exit radius. Exit radius of taxiway. Very, very important for us. There are three conditions. This comfort condition. Next is Haronjeff off-tracking condition. Next is IRC specification for ICAO specification, airport na ICAO specification, especially for supersonic and subsonic aircrafts, we have specifications given. So airport concentrate only on the length calculation based upon normal landing, normal takeoff and emergency stop condition plus three corrections. And then in a taxiway, exit radius, that's it. The railway will be discussed along with survey by some other faculty. So these are the areas I want to touch. Any other things, please? Yes, Haronjeff, Paran. So there is one, I am stopping here. There is one surprise offer. If you, there is a 15% of discount on online GATE and ESC courses. On all AS online and GATE and ESC courses, 15% off. There is the code given to you. Using that code, you can get that 15% off. The code is expiring today itself. Tomorrow is expiring tomorrow. So thank you very much. I wish you all the best. I wish you to get into flying colors after the results. So work hard. Don't waste time. Go ahead. Thank you very much. Thank you all. Bye bye. Good night.